Okay, so welcome to this part. What we're going to do here is take a look at rules for exponents. So as a reminder, we talked a little bit about exponents the other day. We used them the other day. The exponent is the little number upstairs. The bottom number there is called the base. The base shows what number is multiplied, and the 3 shows how many times, or how many numbers, right? So 2 to the power of 3, 2 to the power of 3, that means that we have 1, 2, whoops. It means we have 1, 2, 3 2's multiplied together. 3 for the exponents, 1, 2, 3 2's like that. Now, let's take a look here then. Why think about these things in the first place? Okay, well, to point out is that an important area of math is probabilities. Now, it often starts with things like flipping coins and rolling dice, that sort of thing. But you can relate it to our current situation, the probability of getting the COVID virus, or the probability of perhaps your friend or someone getting the virus, right? So this type of thought, what it does is it often creates expressions that have exponents in them. Okay, so check this out. I think we could all agree that if we're flipping a coin, like in the picture, then the chance of getting a head showing is 1 out of 2. In other words, a half. Well, if we had to figure out the chance of getting 3 heads showing, it means we get a head on the first flip and the second and the third. So in math class, whenever the word and shows up, usually it means times or multiply. So the probability of 3 heads, this means a half for the first, half for the second, half for the third. They're all multiplied together, so we can write them as an expression with an exponent. And in this section, we're going to take a look at how to work with this type of expression. Just a related example. Rolling dice instead. Okay, let's say we had to roll we're looking at rolling a 3. Well, the 3 that happens 1 out of 6 times. There's only 1 dice, right? Anything else, we're getting a 2 or 3 or getting a 2 or a 1, 5 out of 6. And so if you wanted to look at a particular situation, chance of rolling a 3 and a 5 and a 2, it means multiplying again, times. Right? And we can simplify, and what do we get? Another exponent up here. So we got to be able to know how to work with these things in order to be successful in our mathematical lives. So if you take a look at the screen there, just reminds you what these exponents, what they mean. And it also points out that you can use exponents with not only numbers, but also letters as well. And so it might be a bit hard to see, but if you count the number of x's that are down here, there are 1, 2, 3, 4, 5 x's all multiplied together. And so we use this shorthand to show that. So for this first one, good people, xxx, that's going to be the same as x to the power of what? That's going to be the same as x to what number goes up here?
3.
3. Perfect. Yeah. How about for the 5s? Can you count, or for the y's, can you count them all there? How many y's do we have?
5, y5.
Let's see.
Y5.
6, right?
6. Let's see.
Y6.
1. Let's take a look. We got 1 there. 1, 2, 3, 4, 5. Yeah, for sure. We got 6 y's that are written down there. Haneen, you okay with that there? Okay, so 6 y's are like that. So we get y to the 6. This is work, for this one, it's kind of working backwards. If we have r to the 5, that's the same as how many r's multiplied together? 1, 2.
5 times.
Yeah, exactly. Just 5 like that. But for the next one, now we start getting a little bit fancier. Let's watch this. If we have 4x to the power 3, it means we have one of those. We have 3 4x's all multiplied together. And we can actually take this a little bit further. What we can do, we can multiply the numbers together, and then we can multiply the letters
64.
together. Yeah, perfect. Shota jumps in. 4 times 4, 16. Times 4, nice, 64. How many x's are multiplied
X.
together? 1.
3x.
Perfect.
3.
So it's, you say it as x to the 3. X to the power of 3, or x to the 3. Sometimes we leave that out, but that's what we get there. See, we got a different one now. And all that happens is the expressions can be a little weirder. But you just keep them organized. You put the numbers together, the x's together, the y's together, and then you're good. See, we have 3 of these. I'm going to run out of space. Oh no, there we go. All right, so number-wise, what do we got?
Minus 27.
Minus 27 it is. Now the x's, how many are
X.
here? 1,
3.
1, and 1. That's right. So we have 1x times 1x times 1x. That's x to
Yes.
the 3, perfect. And now these,
And
there's
Y.
2 here, right? It's like y times
Yes.
y.
6.
Yeah, it's going to be 6. Y times Y there. Y times Y there. Y times Y there. See? You can always write it out longhand if you're not sure there, right? But after a while, once we get to our shortcuts, once we see some patterns, boom, we can get the result there. So let's start getting some shortcuts. Let's start making some observations. From the expression you see there, R3, R to the power of 3 times R to the power of 2. We can work that out, and we can see that it's R to the power of 5. Right? R3 is 3 R's multiplied together. Oops, I'll do it like this. R times R times R, that's the R3. And we get R times R. So for sure we get R to the power of 1, 2, 3, 4, 5. But it'd be nice to make a rule so that when we see these things, we can jump right to the answer there at the end. So what would the, excuse me there, guys, what would the rule be? What rule could we use that would allow us to connect the 3 and the 2 with the 5 that we get at the end, that we get there at the end? You're not going to tell me, keeping it a secret?
Like you mean the rule of like the way how we did the R, like
Yeah,
R times R, and then 2 R's, which is 5.
is there a way to jump from
I
here?
think if we add 3 plus 2 equal 5 through.
Nice. You add 3 plus 2, and that equals 5. That's perfect. Check this out. Let's say you have x2 times x2. xx, xx. You get x to the 4. Does this idea work?
Yeah.
Yeah, for sure. And that is the key. That is the secret then. So watch this. Whenever you have the same base being multiplied, the exponents, they add together. Exponents with an n in there, the exponents add. So check this out. Let's say you add 3 to the 4 times 3 to the 7. Bases are both 3, so that's okay. They're the same. And so we add the exponents together. So this is going to be the same as 3 to the 4 plus 7, which is the same as 3 to the 11. Done. Good work, Anine. Now, We got a couple of other situations to look at in order to get some other rules, shortcuts if you like, some other shortcuts happening. Okay, let's take a look at the screen. Look at this. Now we have expressions being divided. And so we could, I'll show you the workings out here. But the goal is to figure out what the shortcut is, right? If we have r cubed, and when solving these questions, this is a good idea to be able to picture this in your mind. R3 means we got 3 multiplied together. R2, we have 2 multiplied together. And look what happens. R divided by R, gone. R divided by R, gone. We're left with R to the power of 1, which we normally write as just R. Interesting, interesting. Want the rule. What's the secret? Let's say we have x5 over x3. On the top, we got 1, 2, 3. For 5 x's multiplied together. And on the bottom, we got 1, 2, 3 x's multiplied together. So in the very same way, we can divide x divided by x, gone. X divided by x, gone. X divided by x.
X2.
Nice, you beat me to it. We're left with x times x, which is x2. So what's the connection now? What's the secret? How to go from there right to there?
We not add. We're gonna take out.
Nice. So take out, that's for food. What we do, we can subtract. That's the word you're looking for there. Sometimes minus as well. That also counts. Okay, so takeout is for, that's when you order at the restaurant. I'd like to take out some pizza tonight. Okay, but for subtract, minus, that's what we're looking for. So just to confirm, x, we got x to 5 minus 3 is the same as x2. Nicely done. Okay, so just to rewrite it so it looks professional, what's the rule? When the bases are the same, when base is the same and being divided, the exponents subtract from one another. So yeah, x to the 7 over x3. You go 7 minus 3. And that leaves x to the power of 4. Beautiful. Excellent. We now have another situation. A third rule to figure out. What happens with this one? Okay, we'll check this out. We're given this here. It's cubed. Cubed means to the power of 3, by the way. Okay, same, means the same thing. That's an E in there, cubed. So what do we have? We have r squared times r squared times r squared. We have 3 r squareds multiplied together. We saw earlier that when we have the same base and multiplied, that means we add. So looking at these two, that's r to the 2 plus 2. We could do it all at once, right? But got like that. These have the same base that are multiplied. 4 plus 2, and we get a final answer of r to the 6. So what's the connection now between these numbers in the beginning with the number here at the end?
We multiply now.
Nice. So take a look at the situation. Okay, I'll say exponents multiply because that's true and correct. Times is another word for multiply, right? So exponents multiply, exponents times, times together, right? To get the result. When, well, we have an exponent on the inside, an exponent on the outside, a bracket in the middle, right? Okay, so when we have a bracket, when bracketed, I'll say. When the term has a bracket in the inside like that. So let's take a look at this example. Let's see, we got something that looks like x to the 5, all squared now. What is this thing going to equal? Because of the situation, we get x is going to equal, or x to the 5 squared will be x to the power of 10. And then how? Remember, you can always write these out if you forget. 2 x5s multiplied together. 2x to the power of 5s multiplied together. Because they're multiplied and have the same base, these add up. And we get x to the 10. So the shortcut is way better. Saves you some writing, saves some time from your life there. Yeah, good work. So we got 3 rules so far.
So why we didn't say x we multiplied 5 times?
Because that's, oh, I could have done that here. Okay, I could have shown 5x's multiplied together. 5x's multiplied.
I mean to get x10, why we didn't put like x 5 times and then times 2?
Because that means something a little different. X,
It's like x5,
yeah.
like 5 times.
Because x5 gets multiplied by that number.
Oh, okay. Like, okay.
Yeah.
So the number outside the like
The-
the
Yeah.
fractions,
Brackets for sure.
it's how many we multiply the x with, right?
Nice. Check this out. Just to be silly. Let's say we add smiley face to the power of 3.
So 3 smiley face.
Nice. 1, 2, 3. So if we add x to the 2,
2x. Oh,
x.
3x, you mean?
So this is x to the 2 to the power of 3.
Okay.
So you would say 3x squareds.
So
X.
3 times.
Yeah, exactly.
We don't count the number inside the bracket. This is not how many x we have.
Correct. It's the 3 of the inside.
Okay.
Okay. 3 of the inside. We can work this though, and we did before. Same question. 2,
x3.
2 plus 2 plus 2 like that gives x to the 6.
Okay. Okay.
That's good?
So the rule for this, when we have a number with like square sorry, like if we have a number and it's inside the bracket, and we have, like, for example, a number on top of it and a number outside the bracket, we do add, like, you mean, right? We add the numbers.
No, we multiply. And you yourself said that. Check
Yeah,
this.
I'm confusing between this one. Okay, we multiply.
Yeah. Brackets in the middle there. So multiply times.
Yes. No, I mean the other side, you add 2 times 2 times 2, it just give you 6. Why did you add? Why didn't...
Oh, good. Because when you have one thing multiplied by another,
Yeah.
that's when you add.
Okay.
Okay. That's when you add. No brackets there.
Okay.
Okay. Let's try, so with that in mind, let's try these. X3 times X2. What is this going to give?
X
X
5.
6.
Well, let's see. We got a vote for a 5 and then a vote for a 6. How many X's are multiplied here?
3.
Yeah, there's 3 altogether. And how many here?
2.
2.
Right on. So how many in total?
5.
Nice. 5 like that. Watch this. We have X3. We have a 2 like that.
Why did you put 2 on the outside the bracket? Why?
A new question. Question number 1. Question number 2. What does this one look like?
Oh, it's a new question. Okay, never mind. Okay.
Yeah. So what do you get?
So 3x.
X to the 3.
So x to 3. So x6.
It will be X to the 6. That's right. X to the 6. Shota, you okay with that?
Yes.
Nice. Okay.
Can you show us how we get x to the 6, please?
Yeah,
I showed the answer, but I'm confused a little bit.
for sure. This 2 on the outside says we have 2
Times.
2 of these multiplied together. It shows we have 1x to the power of 3 times another x to the power of 3.
I got you. So the number outside the bracket, this is how many times we time x together.
Not, x3 together.
Okay.
Yeah, good. Perfect. How many are in here?
So
3.
what's the rule for this one? Can I write it?
I did earlier.
So when we have,
Yeah, good. I'll do it again here. So when we have brackets so that it looks like this. Okay, the exponents multiply together.
so x3 times x3 times x3, which is, so 5 times.
5 times, that's right. Now that gets to be a lot of writing. So we're trying to do the shortcut.
Mm-hmm.
Okay, so what will it give? X3 to the 5 is equal to x to the power of 15. Okay. In here you could write x3. Okay, but we're trying to we can use that to start with, but trying to get through to here.
And we add the power together, like 3 is 6.
Nice.
Yeah, and we added. Okay.
Yep, perfect.
Yeah.
Okay, good. Right on. So we have another rule to do. Had that up, I'll put it back. Well, let's see. Yeah, this one. On our screen on the left now. So watch.
X, Y.
This is what we have. We have 3 of these all multiplied together.
Okay.
So we have 1, 2, 3. We can move the order around. So we have x times x times x.
Which is 3x.
X to the 3. Haneen, check this out. When you say 3x, whoops, 3x, that's this.
Oh, x to the 3, right.
Yeah, nice. If you want this, that's x to the 3. We want this one today. Yeah, so perfect. X to the 3. And how about those y's? Y to the
3.
Yeah, perfect.
Okay.
Okay, so we got to figure out the rule. We just have one example here. Gets us this. Let's do another one. How about 3x squared to the power of 2 like this.
Mm-hmm. So 3x and times by 3x square.
Nice. 3x squared times 3x squared.
Nine.
Yeah, it'll be 9, but check. Yeah, 9 for sure. And how about the x's?
4.
I think 1x. So 3x, 4.
3 and 3 multiply
I
together.
think I'm confused. Oh, so 9.
Mm-hmm.
3 times 3, which is 9. X and x, which is
4.
x to 2. X2. X and then 2 in the top.
There's a 2 there. There's a 2 there. So we add them together.
Which is 4.
Yeah. So sorry, Shado. Shota.
Shota.
I know. Okay, so x to the 4. Now we got to get the rule. So this 9, I'm going to help you guys. 9 is the same as 3 squared. So how to jump from there to there?
We're gonna add 2 to 4, which is 3, 8.
No, this is the final answer. That's the final
Okay.
answer there.
Okay.
But the goal is to make the connection between here at the start to here at the end.
Mm-hmm.
What's the trick?
We times 2 times 2, which is 2, 3. We times together.
Nice. Okay, so this 2 on the outside, first of all, it goes to each thing on the inside. What's going on over there? There we go. Muted for a little bit. This 2 on the outside goes to each thing on the inside. So watch. 3x squared looks like. This 3 gets the 2.
Oh, okay. Got what you mean.
Yeah. And this gets the 2 as well.
And
You see?
x2 squared. Yeah.
Perfect.
Which
So
is 9.
it is, yeah. And then x4, right?
Yes.
Because we multiply in this situation.
Yeah.
Yeah, so it would be 9, but the goal is to get the rule. So how do we write this down? I'll keep it up. How do we write it down? I think like this. When you have the exponent outside, outside brackets, that goes to each on the inside. Shota, what do you think of that? See what this says. For example, we have, I'm going to make this bigger. Let's see, 3x squared y4 to the 3 like that.
27.
It will be as the final answer. But to show the rule, I want to show this step here.
Okay.
Each thing in the brackets gets that 3. So this 3 is on that 3. This 3 is on the x squared.
X.
And it's also on the y to the
Y.
4. Perfect. All right. So Shota, 100%. 27 there. Haneen, what's the next?
Yes.
I can't see the paper.
What? It's on this. Oh, is it too small for you? Is it on your phone?
No, yeah, it's moving. So 3x2 just okay. So 27.
Yeah.
Is that a new question or the rest of the?
This is the next step to show you. This 3 goes to each thing on the inside.
Okay. So 3 times 3 is 9. Wait.
3 3s are multiplied
I
together.
think how how about 3 times 3? It's 9, and then we add the number in the top, like 2 plus 4. No, right? I think I'm confusing.
Yeah, that's right. Because the rule is the following here. This is the starting question right there. And what I'm showing is that this exponent 3 on the top, it goes to each thing on the inside. So it goes to the exponent on the 3.
Yes, I understand this part. So 3 like triple 3. Where do we say the number 3 on the top of the bracket?
To the power.
Yeah, 3 to the power of 3,
Nice.
and then 6 squared to the power of 3, and then y fourth and to the power of 3.
That's true. That's what we got.
But we got 27. How we can say that? So
Oh,
3 times 3, it's 9.
yeah,
Times 3. Is that what I'm saying?
that's exactly what you're saying. Smiley face right there. Perfect.
Okay.
Okay. Over here. How do we figure this out?
2 times 3. So x square of 6.
X to the power of 6.
Power of 6.
Yeah, good. And Shota, the last one? Hang on.
3 4
Hang on.
y
Y.
to the power of 12.
Let's see. Shota, what'd you say?
I cannot see the Y and 4.
Yeah,
12.
12. Perfect. Okay, good work.
But how did you get the 27?
3 3 3.
How
3
did you
3
get the
3.
27 from? Can you repeat this, please?
Yep. This first part is this means 3 times 3 times 3. 3 to the
Sorry,
power.
3 times 3.
3 times 3.
Ah, okay, I got it now. I thought I multiplied the 3 times 3 times 3 times 3, which is more than 27.
That's right. That would be
Yeah.
that would be a 4 up there.
Yes, I misunderstood. Now I'm clear.
Yeah, good. Perfect. Okay, so we've done now 1, 2, 3. We've done 4 rules. That's pretty good. And I think that might be it.
Okay, let me check.
Oh yeah, a couple examples.
Yeah, that's better.
Yeah, good. So on the screen, a couple of easy examples. What's the answer to the first one?
Sorry, which question you want?
I'm looking at the screen here on the left. We have 2 to the 3 times 2 to the 2. So what is this going to work out to be?
I think the paper is upside down. Okay, I got it.
I hope not.
No, it's not. It's good.
Yeah.
3 to the power of 7 and 3 to the 2 to the power of 2. Okay, equal.
Okay, let's do the first
Um,
one. Let's do the first one first. 2 to the power of 3 times 2 to the power of 2. What is this going to equal?
um,
Shota, you got this one?
Yes, I got it.
2.
Nice. Okay, so Shota 2 to the power of what?
I got only answer.
What did you get? How many 2's are multiplied here?
33,
How many here? That's a 2.
2,
How many altogether?
5.
Nice. You add, in this situation, 2 to the 5. Good work. The
So,
next,
Mr.
yeah,
When the base is equal, we put the base without adding any number. The base come the same number.
base is
For
this,
example, I don't say for the power of 5. It's wrong, right?
it's wrong.
But if the base is equal, but the what do we call the top number is different, we add the top, but we put the base the same number. We don't add it or multiply it or
Exactly.
yeah, right. So this is I'm trying to understand.
Yeah, that's good.
Okay.
Excellent. The same is going to happen for the next one.
So I'm gonna confuse between when we're gonna add the top and when we're gonna subtract the top. Like when we're gonna minus and when we're gonna add. So I have to to organize the rules and then see the difference so I don't get wrong answers in the question.
Yeah, perfect. I'll show you here.
I will understand it like in the future when we have more practicing.
Yeah, when you have multiplying, when things are times together, that's when you add. When things divide, then you
What
minus.
do you mean when we time? What do you
Okay,
mean by when we add times together we add?
good. Look at the question right here. We have a 2 times by 2.
Okay.
And so,
Oh, okay.
because it's timesing, we add together.
We add the top number, not the base number.
Yep.
Okay.
Okay. Now, looking at the
Yeah,
next
it's it's
question on
it's,
the,
it's good.
yeah, look at the next question on the slide. Remember this, when we divide, we subtract. So that looks like this now.
Okay.
We're dividing. Same base, same base. So we get the same base.
Okay. Same base. Okay.
Yeah. And then what happens with the exponents?
We're gonna divide it.
The exponents are divided.
We're gonna subtract it, sorry.
Nice. 7 minus 2. Same base. Exponent of 5.
Okay.
Yeah. Okay, so that's good there. Yeah, some more questions. Check the screen on the left. We got -4 to the power of 2, -4 to the power of 3. Are these multiplied or divided?
Where do you, I can't see your, where, which, oh, -4, I see it now.
Yeah.
It
Right.
takes time to go to the slide.
Okay.
So -4 to the
Mhm.
power of 2. And then the dot, is that mean we multiply together, right?
That's right.
-4 to the power of 3, right?
Yep.
Okay.
Final
So
answer?
we'll say final answer for this. Um.
-4.
Good.
So -4 to the power of 5.
Haneen says 5. Shota, what do you say? 5 as well.
I think so. 5.
Nice. Good work, you guys. Okay, so that's good for that
But
one.
we don't put minus. We put the number without the minus, right? Because it's the same sign. So minus and minus goes together or not? Or what do you think?
Oh, good. The base stays the same. So it's a -4. So it stays as a -4.
Okay.
Okay, yeah, good question. -4, -4, -4.
Yeah, I got it.
Okay. The next one, I think
So
we
what?
did.
So the rule of this one, it's when we have the same base, but the power is different, which is the top number is different. We do the same, the second rule, divide, we subtract, right?
Perfect.
Same number 2 rules, right?
Perfect. Yeah.
Okay.
X7, X2, they're divided. So you subtract. X7 minus 2, we get X to the 5.
Yeah.
Yeah.
Yes.
Okay, that's good. Well, we've seen something like this before. Let's try it again.
Yes.
How does this one work?
Okay. 3x. So 3x.
Seven.
How about 3 to the power of 3 and then x to the power of 3?
Nice. Each thing gets it. The 3 gets the 3. The X gets the 3. Looks like this. Perfect. 27. X to the 3.
So the 27, you got it from 3 times 3, which is 9. Where do you got the 27 from?
This came up earlier. So remember, 3, this 3 here, 3 things multiplied together. So it means
Yes.
3 times 3 times 3. 27.
You know what? You know how I understand how was my mind understanding this before you said this right now? I was thinking 3 times 3, which is just 2, 3 times to calculated like 3 times 3 times 3. Now it's more understand.
Ah, good. All right.
I still like having trouble with this, but now I understand.
Nice. Ooh, look at the next one. Okay, so for the next one, what we'll do is you work on the numbers first.
-6.
-6, Shota says, and I agree, perfect. Now, the x's, we got
X
2 there and an invisible 1 there.
2 1. Yes, 3.
Nice. x3. And then we have a y3 times a y to the power of 2.
5.
Perfect.
Where did you get the minus x from?
-6 from that -2 times that -3. Oh, that +2 times the -3.
Okay.
So
So
the
2 times -3, which is minus x, right?
yeah. Exactly. Oh, look at this.
So we add the top and we times the each number with each side, right?
Yeah.
Yeah, that sounds good.
Okay. That's good. So let's go to the next. Excuse me. Let's go to the next one. 2 to go. With this thing, it's a good idea to simplify inside the brackets first. It'll just make life.
X
It'll make life nicer. So we have this in the first bracket. That's in the second. So you see there's y cubed on the top and y on the bottom. Let's simplify
yes,
those first. So what do we get?
X Y
xy to the power of
2.
2. Nice. Haneen, you okay with that one?
I'm confused.
Okay, what you see, we got it's a pretty big question. Top, bottom, multiplied. So we take a look at the first bracket only, at this one. We got y3 on the top and y on the bottom. So because we're dividing, the exponents, they subtract. So we have a 3 minus a 1, which is invisible. 3 minus the 1 gives the 2.
So you minus the 3 on top of the
That's right. There's an invisible 1 with this y right here.
one we can't see it. Okay.
Yeah, exactly. Minus because we're dividing. Let's do the same.
Okay.
With x this time though, right? X to the 3 on the top, over x to the 1 on the bottom. What do we get?
Mm, X, Y.
There's going to be a y there for sure. Y to the 2. But we have x to the 3 divided by x to the 1. So what happens with the 3 and the 1? Because we're dividing.
We subtract.
Nice. We subtract.
We're gonna subtract. So x2.
Perfect. X to the 2. Y to the 2 like that.
And then y to the 2.
Nice. Next, we put the x's together. So that means x to the power of?
To the power of 2.
2 over there. There's an
3.
invisible one there.
It's
Perfect.
x to the power of 3.
Yeah. And
And then x to the power of 4. Y to the power of 4.
I'll take y to the power of 4. You got it. 100%. Just like that.
So now when we are doing so I'm confused now why we didn't minus the x so 2 times minus, sorry, so there's x that indivisible x and x to the power of 2, right? The second part, not the top.
That's a 3.
No, not this one. When you did the second one, down, yes.
Yeah.
So you put x, y, the power of 2, and then x, the power of 2, and then y, the power of 2, right?
Perfect. Yeah.
And we did minus, we did add here, we didn't minus, right?
That's right. Times means adding. We're not dividing these x's. They're all on the same level. So it's x times x squared. So we add. Okay, good. I think there might be one more. Then that will finish up the examples and you guys can practice with the homework. Yeah, I got to show you this one. Something special. Whenever you divide by a fraction, what you do is you multiply and you go 1 divided by the fraction. Here's an example from numbers. If you have 1 divided by 2 over 3, it's the same as 1 times 3 over 2. See, the second part turns upside down. So the question we have, what you need to do is switch it to times right away. Oh, I'm going to put a dot for times, just so it doesn't look like x's, okay? So a dot for times, and this fraction goes upside down. Upside down means y to the 2 is on the top, and 2x is on the bottom. Okay, now we have two fractions now that are multiplied together. And so you always do the top times the top, then bottom times the bottom. Top times the top over bottom times the bottom. So that's going to look like this. 4x cubed y cubed over 2xy squared, like that. Now we do have to simplify the question. That's why we're here. So we have to keep track of our rules. So we have a 4. We'll do the numbers first. 4 divided by 2 is equal to 2. We have x3 divided by x. So that means the exponents subtract one another. Yeah, minus, subtract, for sure. And yes, it will be a 2. I'll put it in the next step. And then the y's are divided as well.
Why?
Perfect. 2x2 y. Well, okay. So here's what that takes us to the end then. So what I'd like you to do, well, first of all, any questions?
Nothing.
Nothing, okay. Then what'll happen is
Yes.
you can go to Teams. Shota, you got to go from the start, from day 1. Read over everything. And then go to day 2. And then day 3. For Haneen,
Okay.
I'm putting putting today's homework questions up for you. They'll be in a folder called Day 3. That goes there. That goes there. And those are the homework, the questions to practice for homework. Okay, so I'm just I'll leave it there. And we'll plan to resume again next time.